Welcome to our discussion topic of the day. My name is Teacher Faith, and I'm going to take you through sulfur and its compound, and we're going to work out the flowchart questions under this topic so that it can be easy for you to understand how to answer questions under this type of gas. Now, let us start. So we know sulfur is a gas just like oxygen, hydrogen, carbon, nitrogen, and chlorine. Now, sulfur being a gas, sulfur is a gas which has covalent bonds between it, okay, between each sulfur molecule. So we say between one sulfur. So sulfur as a gas forms a molecule with an S8 ring, okay? It forms an S8 molecule, meaning so let us draw. If this is one sulfur atom, okay, so you have a covalent bond between one sulfur atom and another sulfur atom, okay, and so each sulfur atom, we have 8 sulfur atoms which are bonded to each other. That is why we are saying it forms what? An S8 molecule. So this is how it's going to look. We have one atom there, the second one, we're going to have a third one, fourth, fifth, the sixth, the seventh, the eighth, okay? That atom is bonded to the other. So this is one sulfur atom, okay? This is another sulfur what? It's another sulfur atom. Remember when we were talking about compounds, we said that we can also represent the bond in a substance using small short lines. Remember we said that, and we said if you see a short line like that, or you can it almost looks like a dash, yeah. This line represents, in chemistry, this represents what? It represents a covalent bond, okay? So we are saying between one sulfur atom and another sulfur atom we have the covalent bond, okay? And again we can also say, and another thing that we need to know is between one sulfur molecule, this is one sulfur molecule, and another sulfur molecule, we have weak van der Waals forces of attraction. So this is one sulfur molecule bonded to another sulfur molecule, and the bond that is between the two sulfur molecules are what? It is the weak van der Waals bond, okay, or force of attraction. So we are going to still form another. So we are going to count them. This is 1, 2, 3. We count together. 4, okay. 5, 6, 7, 8. Covalent bond like that, okay? Now between one atom and another atom, we have said this is what? This is covalent. It is a covalent bond, okay? This is also a covalent bond. It is also a covalent bond, okay? So we have already written there. Now between one molecule, this is one molecule of sulfur and another molecule of sulfur, we have what? Which type of bond? We have said we have weak van der Waals forces of attraction or bond. Don't mind my diagram there I'm drawing, but I know like you have understood what I'm trying to mean, yeah? So there's a way it is like that, yeah? So this is just to show you how it is. You can look at the proper diagram in your textbooks, but this is how it is. Between one molecule and another molecule, we have which type of bond? Weak van der Waals forces of attraction. But between one sulfur atom and another sulfur atom, we have the covalent what? The covalent bond. Now, why is it important to know this? It is important to know this because sulfur has allotropes. Because sulfur has allotropes. The allotropes of sulfur are which one and which one? We have 2. We have monoclinic and we have rhombic. So that is sulfur, okay? So here we have 2 things. We have a solid A, we have air, and then you can see we have sulfur 4 oxide. Air, our sulfur 4 oxide and air goes to our purifier. From our purifier we have sulfur 4 oxide and air. And then we also have the sulfur oxide and air, they are taken to a dryer, then to something, what is this? And then here, and then to an absorption tower, where the absorption tower, we can see there is an intake of sulphuric 6 acid, and then we have oleum, and then we have a diluter, and then we have that blank we're supposed to answer. And the whole process is referred to as a contact process or industrial manufacture of sulphuric 6 acid. Now, what are the raw materials? First of all, we need to have sulfur. Okay, the raw materials are what? The raw material is sulfur, and then we have what? We have air here. So our air, we are talking about what? We're talking about oxygen. The active part of air that we're interested in the whole process is what? It's oxygen. Now, sulfur and oxygen is going to react here to give us sulfur oxide. So they want us to say, what is this? Now, the first step is sulfur and oxygen are going to react. This is the combustion or a chemical property of sulfur. So sulfur plus oxygen. Sulfur plus oxygen, what do you get? You get sulfur for what? You get sulfur for oxide. So this is combustion. This whole process, you're saying it's what you call combustion. So where is combustion going to take place? Combustion is going to take place in a furnace. Okay, so here we can say it's called a furnace, or alternatively you can get it maybe referred to as a what? As a roaster. Okay, so we are going to have sulfur and oxygen reacting in the furnace or in the roaster to give you a sulfur for oxide. Okay, so we have now the sulfur for oxide that was formed, and air also, and some part of the air that didn't react, or some part of your air going to a purifier. Now, what is the purpose of a purifier? Purifier, what does purifying means? Purifying is like cleansing or cleaning something. Okay, so what is happening here? Remember, in the contact process, we are going to have a catalyst that is going to help us in the formation of sulphuric 6 acid. So we take our air through the purifier in order to do what? To prevent poisoning of what? To prevent the poisoning of the catalyst. Now, what is the name of the catalyst that is going to be used up during the contact process? The catalyst is, we talk about what? Vanadium to vanadium 5 oxide. Okay, so the catalyst is vanadium 5 oxide. Okay, that is our catalyst in the whole process. Now, this purifier is going to remove dust. So the purifier is going to remove dust. Okay, so the purifier is going to remove, one thing that is going to remove is dust. The second thing that the purifier is going to remove is the remaining water vapor, the water vapor in air. Okay, so we are going also to remove, I'm writing here as gas because if it is H2O gas, it means it's water vapor. Okay, so water vapor, let me just write water vapor. We are also going to remove water vapor. Another thing that you're going to remove from the purifier is what? Arsenic, some of arsenic compounds that are present there. So after we have purified our air, now we know our catalyst cannot be poisoned. So we take our sulfur oxide and air that is going to be passed through the dryer. Okay, now in the dryer we are going to do what? Dryer means you're drying something. So this is a drying tower, and in our drying tower we are going to absorb the water vapor that is in the air. The remaining water vapor is going to be absorbed here. So here we are going to say we absorb water what? We absorb water vapor. Okay, now so we have our sulfur oxide and we have our air which is free. Let me write here. We have our sulfur oxide and our air which is free from dust, arsenic compounds and water vapor. So here we have sulfur oxide and oxygen that is going to be taken to this chamber. So they want us to label that chamber. Now we know, personally, if it is an exam, if you see something like this, always know that that is what you call what? It is your heat exchanger, okay? It is the heat exchanger. So this you're going to label it as, let me stand on this side. So this you're going to label it as a heat what? It is our heat exchanger. Okay, this is our heat exchanger. Now, what happens in the heat exchanger? In our heat exchanger, the first thing that we're going to do is we are going to, one, increase. Okay, in our heat exchanger, we are going to do what? We are going to increase the reacting temperatures of our gases, which is sulfur oxide and what? And oxygen. So we are saying here the first thing that we do is we increase the reacting temperature. I hope everyone can see here. Okay, so we increase the reacting temperature of our gases or of our products, which is what? The reacting temperature of sulfur oxide and what? And oxygen. Now, why is it? Why are we increasing the temperature? Because for us to form sulfuric 6 acid, the first thing we have to do is, one, form sulfur oxide. By reacting sulfur and oxygen, I think up to there we are fine, right? Now, after you formed your sulfur oxide, and it has been taken through the purifier and the dryer, your sulfur oxide, once you have formed your sulfur oxide, the sulfur oxide is again going to be oxidized, or we are going to further react it with oxygen to form sulfur 6 oxide. Okay, from the sulfur 6 oxide that we are going to form, we are going to react it with sulphuric 6 acid, and then we are going to react the product that we would have formed, which is oleum, with water for us to form what? Our sulphuric 6 acid. So that is why we're increasing the temperature for the reacting gases, which is sulfur oxide and what? And oxygen. Now, the other thing that we're doing in the heat exchanger is what? The other thing is we are going to cool the product. Okay? The reacting temperature of a product with sulfur oxide and oxygen. Okay? So here we are going to also, in the heat exchanger, we're going to cool the products. We are going to cool the products preventing decomposition. We are going to cool the product preventing what? Preventing decomposition. Preventing decomposition of sulfur 6 oxide. Up to there, I believe you're fine. Okay? Why are we preventing the decomposition of sulfur 6 oxide? Now, let us talk about the third thing that is happening here, and then we explain this. The third thing that is going to happen in our heat exchanger, let me write it up here. The third thing is we are going to recycle the heat. Okay? Recycle the heat in order to reduce the production cost of our sulphuric 6 acid in the industrial process. Okay? So here we recycle the heat. I hope everyone can see there. To reduce the production, to reduce the production what? To reduce the production cost. Okay? Let me to this side now. To reduce the production cost. Now. Why are we've said we are going to increase the reacting temperature, and we're also going to recycle the heat to reduce production costs, and also to cool the products preventing decomposition of sulfur 6 oxide. Now, that point. Remember, sulfur 6 oxide, sulfur 6 oxide can easily decompose, okay? And if sulfur 6 oxide decompose, what is going to happen? We are going to have low production of our sulphuric 6 acid. And remember, that is what you want to produce. And if it is an industrial process, then it means you want to maximize the production. But if we have decomposition of sulfur 6 oxide, we are not going to have maximum production of sulphuric 6 acid. Now, that is a question you're normally asked there. Now, we have now our sulfur 4 oxide that has been formed there. Now, from our heat exchanger, we have also a catalytic chamber that is supposed to be up here. So we have a catalytic chamber. We have a catalytic chamber there, okay? And in our catalytic chamber, okay, so we have a catalytic chamber that is coming through. You can see the arrow of from the catalytic chamber to our heat exchanger, okay? And we also have an arrow that is coming from the heat exchanger to the catalytic chamber. Now, we're saying that the sulfur 4 oxide and the oxygen that is here is going to come into our heat exchanger, then go to the catalytic chamber, where we are going to have now the catalytic oxidation of sulfur 4 oxide with air. That is that we are going to have sulfur 4 oxide. We have said we're going to have catalytic oxidation. That is, we are going to have your sulfur 4 oxide in our catalytic chamber, okay? Sulfur 4 oxide reacting with oxygen to give you what? To give you sulfur 6 oxide. Up to there, we okay? And it is in the presence of what? It is in the presence of a catalyst, which you said it is what? Vanadium 5 oxide. Now, this reaction is what? It is reversible. And that is why we have said that the process that is involved in the heat exchanger includes what? One is prevention of the decomposition of the sulfur 6 oxide that was formed in the catalytic chamber, and it has passed through our what? Our heat exchanger. So we are going to balance our equation by putting, we say you start balancing the number of oxygen atoms. So we are going to balance our equation by putting a 2 where? Putting a 2 there. Now here we have our sulfur 6 oxide coming to our compressor. Now, from the compressor, we can see something here. Now, if you see a compressor, what does compressor mean? So this is a marker pen. If I want to compress it, what do? I hold it like this and I press it, okay? It's going to do what? What is supposed to happen? It's supposed to, like, if you press it, if you take something and you want to press it, you're holding it like this. It's going to reduce in size. Once it reduces in size, what happens? We talked about it in gas laws. You increase the pressure, okay? So in our compressor, we are going to increase what? We are going to do what? To increase the pressure of our reacting gas, okay? So in our compressor, we increase the pressure. Even you can see compressor, you have pressure. It's about pressure. So here we are going to increase the pressure of our reacting gases, and then we are going to have now our sulfur 6 oxide being taken to our absorption tower, and in our absorption tower we are going to have our sulfur 6 oxide reacting with concentrated sulphuric 6 acid. As you can see, we have an intake of concentrated sulphuric 6 acid in the absorption tower. So the sulfur 6 oxide and concentrated sulphuric 6 acid are going to react to give us a product that is referred to as oleum. They have already given you here. So what is the formula of oleum? H2 S2O7. And let us look. When you're balancing, you start by balancing the number of hydrogen atoms. Are they balanced? Yes, they are. What about oxygen atoms? Are they balanced? We have 7 here. 3 plus 4, it's 7, okay? Sulfur 1, 2, 2. So it is balanced. So the formula of oleum is H2S2O7. Now, our oleum is taken to our diluter. Dilution. So this means we have what here? We have water. Do you see how simple it is to understand some things? Like, for example, you have purifier. You're purifying, you're removing dirt, you're making it cleaner. It's like you're cleansing it, yeah? So, dilution, you're putting water, okay? So here in our diluter, we know that we're adding what? We are adding water to our oleum. Now, let us add water. The final product is what? It is a contact process and it is involved in industrial manufacture of sulfuric 6 acid. So even without writing the equation, we know that the last product here needs to be what? Sulfuric 6, concentrated sulfuric what? 6 acid. Isn't that simple? Now let us write the equation. So we have our oleum, H2S2O7. You react it with your water, okay, to give you your concentrated sulfuric 6 acid. We balance hydrogen atoms, 2 here, 2, okay, here we have 2, here we have 4, and then now we are going to balance it because we said we have to balance the number of hydrogen atoms first. If you balance the number of hydrogen atom first, you go to oxygen if the equation is not balanced. Normally, when you balance hydrogen first, yeah, there is a probability of the whole equation being balanced. If it isn't balanced, you go and balance oxygen. Trust you me, if you have balanced hydrogen and oxygen, chances are your equation is balanced. If it is not balanced, you go to the next item. So that is the rule of balancing. Start with hydrogen, then oxygen, then the other element. I have also talked about the equation balancing, so you can also check there if you have issues. And if you want more guidance on that, you can contact me. You have my info on my channel and then I'll help you, okay? Now let us balance. 2 hydrogen, 4 hydrogen here. We balance by putting a 2, 4 hydrogen, 4 hydrogen. 8 oxygen, 8. Sulfur is 1, sulfur is 2, but no, sulfur is 2, sulfur is 2. Told you what? If you balance hydrogen, your equation is most probably what? Balance. Now you have formed your sulfuric 6 what? Sulfuric 6 what? Sulfuric 6 acid. Now, it is important to note that the sulfuric 6 acid that is formed in the process or this contact process or the product formed is normally 98% sulfuric 6 acid and 2% what? 2% water. Okay. So that is the whole process that is involved in the production of our sulfuric 6 acid, and it is called contact process or industrial manufacture of sulfuric 6 acid.